So welcome, this is the past paper questions based on the topic logarithms. So the first question, log 6x to the base 2 equals to 1 plus log y to the base 2. So what am I going doing? I'm converting everything in terms of log base 2. So it becomes log 6x to the base 2 equals to 1 can be written as log 2 to the base 2 plus this becomes log y square to the base 2. So it becomes log 6x to the base 2 equals to log 2y square to the base 2. So we can cancel log base 2 and log base 2 gets cancelled. So what do I get it out? 6x equals to 2y square. That is the first equation. Now coming to the second one. 1 can be written as log 6 to the base 6 plus log x to the base 6 equals to log 15y minus 25 to the base 6. So it becomes log 6x to the base 6 equals to log of 15y minus 25 to the base 6. Now again log base 6 gets cancelled. So what do I get? 6x equals to 15y minus 25. We can clearly see that both are 16x or 6x. So what does that becomes? 2y square equals to 15y minus 25. Then you get a quadratic 2y squared minus 15y plus 25 equals to 0. Factorize it at 2 minus 5 times y minus 5 equals to 0. So we get either y equals to 5 upon 2 or y equals to 5. Now we have to get the value of x over there. So when I plug in that 6x equals to 2y square, 6x equals to 2 times 5 upon 2 square. This gives me the x value as 25 upon 12. And next time 6x equals to 2 times of 5 square. This gives me x value as 25 upon 3. That's going to be the answer. Coming to the second question. Ln x whole square minus ln 2 times ln x is less than 2 ln 2 whole square. So let ln x equals to y. So it becomes a quadratic y square minus ln 2 times y minus 2 ln 2 whole square is less than 0. If it is a quadratic, you can factorize the quadratic, or you can use the formula y equals to minus b plus or minus square root of b square ln 2 whole square plus or minus 4, a is 1, c is negative 2 ln 2 whole square divided by 2a, 2 times of 1. So what does that becomes now? Ln 2 plus minus square root of ln 2 whole square plus 8 ln 2 whole square divided by 2, which is 9 ln 2 whole square. So y equals to ln 2 plus or minus square root of 9 ln 2 whole square divided by 2. 9 ln 2 whole square is 3. So y equals to ln 2 plus minus 3 ln 2 upon 2. So once I take positive value, once I take the negative value, y equals to ln 2 plus 3 ln 2 upon 2, or y equals to ln 2 minus 3 ln 2 upon 2. But y value is nothing but what? Ln x. So ln x equals to 2 ln 2 and ln x equals to minus ln 2. So ln x equals to, this is ln 4. So x equals to 4. Ln x equals to ln 2 power minus 1. So x equals to 1 upon 2. Those are the answers. Coming to question number 3. Show that this can be written in this form. So what am I going to write there? Log x r square to the power of 1. This 1 comes to the numerator, 2 comes to the denominator. So it becomes 1 upon 2 log x to the base r, which is asked us to prove. It is given that this entire thing equals to 0. The region bounded by r and the graph. So this comes under the calculus. So once we do the calculus topic, we can do that one. For the present moment, we can leave it over there. Then coming to question number 4. Find the values of a and b. The relationship between ln x is given by ln y equals to a ln x plus b. Find the values of a and b. So ln x equals to ln y equals to a ln x plus b. So I take any two particular values. So 5.63 equals to a times 1.10 plus b. And similarly 5.22 equals to a times 2.08 plus b. Then subtract both. B and B gets cancels. 5.63 minus 5.22 is going to be nothing but what? 0.41 equals to A times minus 2. What is this? 1.10. 1.10 minus 2.08 will give me negative 0.98. From this, I'll be getting the value of A as minus 0.454. Plug in the value of A in any one of the equation. I'll be plugging in the first equation. So 5.63 equals to minus 0.454 times 5.63 equal to minus 0.454 times 1.10 plus B. This gives me the B value as nothing but what? 6.14. Use the regression equation to estimate the value of Y when x equals to 3.57. So what is the equation we got it out? Y equals to minus 0.454 ln of 3.57 plus 6.14. Now plug in the value of what is this? X over here. So which we have substituted as 3.57. Simplify that one, which will be ln y. So ln y equals to 5.56484. So y equals to e to the power of 5.56484, which is equals to 261 in three significant figures. The relationship between x and y can be modeled as y equals to kx to the power of n. By expressing ln y in terms of ln x, find the values of n and k. So applying ln on both sides, so it becomes ln y equals to ln kx to the power of n. So what does that becomes? Ln y equals to ln k plus n ln x. Then we can clearly see that what is the equation he has been given in the question? Y equals to, the equation given in the question was a ln x plus b. A ln x plus b. So we can clearly make it out that n equals to a and b equals to ln k. So what was b value? B value we have found it as 6.14. So we take the full calculator display over there. So b equals to ln of 6.14210. So k equals to e to the power of b value is 6.14210 equals to ln k. So k equals to e to the power of 6.14210, which is going to be nothing but 465.030. And n value is itself is a. So n equals to nothing but what? Minus 0.454. So we got the value of n and k value. That is being asked us to find it out in this question. Question number 5. Solve to get this one. So both are base log 2. So addition becomes multiplication log base 2. X plus 3 times x minus 3 is x square minus 3 square, which is 9. So x square minus 9 equals to 2 power 4. X square equals to 25. X equals to plus or minus 5. But minus 5 is rejected. So x equals to 5 is only the answer. Next, again both are base log 2. So Get all the log terms on one side. Log x to the base 2 minus log 5 to the base 2 minus log 3 to the base 2 equals to 2. So it becomes log x divided by 15. 5 times 3 is 15 to the base 2 equals to 2. So x upon 15 equals to, converting logarithmic form into exponential form, 2 square. So x upon 15 equals to 4. So x equals to 15 times 4, 60. Question number 7. So this is log base 10, 1 upon 2 root 2 p plus 2q equals to 1 upon 2 log base 10 pq. Now this 1 upon 2 goes to the power, it becomes root. So log base 10, 1 upon 2 root 2 p plus 2q equals to log base 10 square root of pq. What can I do? Log base 10 gets cancels. Then I get 1 upon 2 root 2 times p plus 2q equals to square root of pq. I am squaring on both sides. So it becomes 1 upon 8 p plus 2q whole square equals to pq. So p plus 2q whole square equals to 8pq. Expand that one. P square plus 4pq plus 4q square equals to 8pq. So 4pq minus 8pq is minus 4pq. P square minus 4pq plus 4q square equals to 0, which thus becomes as p minus 2q whole square equals to 0. So p equals to 2q. He's asking find p in terms of q. So p equals to 2q. Question number 8. 4 power x can be written as 2 power 2 whole square, 2 power 2 whole power x. 2 power x plus 2 can be written as 2 power x times 2 power 2 equals to 3. So it becomes 2 power x whole square plus 2 power x times 4 equals to 3. So let 2 power x equals to y. 2 power x equals to y. So it becomes y square plus 4y minus 3 equals to 0. So it is a quadratic. We factorize is not possible. So therefore you use the formula minus b plus minus square root of b squared minus 4ac. C is itself is negative 2, 3 upon 2a. So it becomes negative 4 plus minus square root of 28 upon 2. 28 is nothing but what? 2 root 7. 4 times 7 is 28. So 2 root 7 upon 2. So I get y equals to negative 2 plus root 7, or y equals to negative 2 negative root 7. Negative 2 negative root 7 is rejected because y cannot be negative. So only the positive value. So 2 power x equals to negative 2 plus root 7. Applying log on both sides. So x log 2 equals to log of negative 2 plus root 7. So x equals to log of negative 2 plus root 7 divided by log 2. This is going to be the answer for question number 8. Now question number 9. The series ln x plus p ln x and so on is geometric. Show that p equals to. It is geometric. Geometric means the common ratio should be the same. So second term upon first term should be equals to third term upon second term. Second term is nothing but what? P ln x upon ln x equals to third term 1 upon 3 ln x upon second term p ln x. So p equals to 1 upon 3p. So from there 3p square equals to 1. Then p square equals to 1 upon 3. So p equals to plus or minus 1 upon root 3. Hence or otherwise the show that the series is convergent. So we can see that if it is convergent when r is lying between negative 1 and positive 1. So we can see that for both the values we have to find it out the common ratio. Common ratio is nothing but what is the common ratio? P. We can see that P is either minus 1 upon root 3 or plus 1 upon root 3. It lies between negative 1 and positive 1. So therefore it is convergent. And S infinity is 3 plus root 3. Find the value of x. S infinity means nothing but what? U1 upon 1 minus r. So which is 3 plus root 3 equals to U1 is ln x upon 1 minus r, 1 upon root 3. So from there, what do I get? 3 plus root 3 equals to root 3 times ln x upon root 3 minus 1. Then I do the cross multiplication. Ln x equals to 3 plus root 3 times root 3 minus 1 divided by root 3. So I can take root 3 common in these both. So root 3 common means it becomes root 3 plus 1 times root 3 minus 1 divided by root 3. What's the point? So that root 3 can be cancelled. A plus b times a minus b is a square, which is root 3 square minus 1 square, which is nothing but how much? 3 minus 1, which is 2, which is what are we asking? Ln x. So x equals to, converting logarithmic form into exponential form, x equals to e square. That's going to be the answer. Now consider the case where the series is arithmetic and find the common difference. Show that p equals to 2 upon 3. So u2 minus u1 equals to u3 minus u2. u2 is p ln x minus ln x equals to 1 upon 3 ln x minus p ln x. So we can see that ln x, ln x, ln x, ln x, it cancels. P minus 1 equals to 1 upon 3 minus p. So it becomes 2p equals to 1 plus 1 upon 3. 2p equals to 4 upon 3. So p equals to 2 upon 3. Write down the value of d in the form of k ln x. So d is nothing but what? The common difference. What was the common difference? We have found it out. u2 minus u1, which is p minus 1 ln x. Common difference is nothing but what? u2 minus u1, which is p minus 1 ln x. So p is nothing but what? 2 upon 3 minus 1 ln x. So it becomes minus 1 upon 3 ln x. That is only asked us to prove it out. And lastly, the sum of the first n terms is given by. So first n terms formula we know. Sn equals to n upon 2 times 2u1 plus n minus 1 times d. So n upon 2 times 2u1. What is u1? Ln x plus n minus 1 times d. Common difference is minus 1 upon 3 ln x. So what does that becomes? We can take ln x common. So n ln x upon 2 times 2 minus n minus 1 upon 3. So it becomes, and what is he told that? Sum to first terms is ln 1 upon x cube. So this equals to ln 1 upon x cube. So ln x to the power of minus 3. So minus 3 ln x equals to, we get n ln x upon 2 times 6 minus n plus 1 divided by 3. We can clearly see that ln x can be cancelled, and do the cross multiplication. Negative 6 equals, what is this? 6 times 3 is negative 18 equals to n times 7 minus n. So negative 18 equals to 7n minus n square. So n square minus 7n minus 18 equals to 0. Now we can factorize it out. N minus 9 times n minus n plus 2 equals to 0. So n equals to 9, n equals to negative 2. Negative 2 is not possible. So n equals to 9 is the answer. That completes this video. See you in the next video. Bye.